So now the time is 6 o'clock. We will wait for a couple of more minutes as usual, and we will start by 6:02 or 6:03. Okay. I hope I'm audible and all of you are able to see my screen.
Hello, sir.
Yeah. Thanks.
Good evening, sir.
Yeah. Good evening.
Sir, can you explain the question from 2021? You have done it, but I don't remember
Uh,
that. That probability question that was related to head and tail.
okay. 2021
Remember?
question. 1 second. Which one you're talking about?
Yes, sir. That was the question.
This is the question that you're talking
Yes,
about?
yes, sir. You
Yeah,
have
this
done
one.
it, but best
Yeah,
can you
okay, I
explain
will.
in the last?
Yeah, I will explain
Oh,
towards the
okay,
end
sir.
end of the session. Yeah.
Okay, sir. Okay, sir.
Okay, now let us start. Now the time is 6:02. So today, as I told in the last class, we can discuss some questions related with probability, engineering mathematics related with probability and statistics in GATE syllabus. It comes under that. So mainly I will deal some questions with probability. Initially, one question is related with this question. As you can see, it's an elementary question. It's a question from 2014 GATE exam, session 1. There were 4 sessions in 2014. So yeah, then I will show you one question that's again from 2014. That's a question related with random variables. That's also very elementary level question. Then we will see some questions that need some more effort to solve, like some questions related with conditional probability. Then I will then we can discuss some questions related with expectations of random variables. Okay. So yeah, so let us start. I hope all of you are able to see my screen. So I will read the question once. So the question is as follows. In a housing society, half of the families have a single child per family, while the remaining half have 2 children per family. The probability that a child picked at random has a sibling is. It's a numerical answer type question. So I think the question is very straightforward. So if you know the answer, you can just unmute and tell the answer. I will explain the solution anyway. So, okay. So in a housing society, say there are some n number of families. Number of families is, say, assume it to be n. number of families. Let us assume that it's equal to n, some number. Okay. And half of the families have a single child per family. That means one half means n by 2 families, and the remaining half is again an n by 2 number of families. So half of the families have a single child per family. Suppose for this half, in every family there is only one child. So number of children equal to, so the contribution from this side is n by 2, correct? Then while the remaining half, the second half, have 2 children per family. That means there are n by 2 number of families. In each family there are 2 children. That means 2 into n by 2. So the total number of children is equal to 3n divided by 2. Is it clear? So now the question is, I am picking one child at random. That means there are total 3n divided by 2 number of children, correct? From that I am picking one child at random. That means, say I am assembling all the children in a big ground or somewhere, okay, and I am picking one children. I do not know whether that child has a sibling or not. What is the probability that the picked child has a sibling? So out of these 3n by 2, how many children will have siblings? Can somebody tell? N, exactly. So the children, number of children with siblings. So whoever is coming from this side means from the families where there are 2 children, correct? So the total number of children with siblings equal to 2 into n by 2, that's again n. So the probability that the child picked at random has a sibling is, what is that probability? So there are total 3n divided by 2 number of children. Out of that, n children have siblings. So what is the probability that a child picked at random has a sibling? Somebody? Can't see anything in the chat window. Yeah, somebody have already told the answer. Exactly, correct. So the probability, the required probability or the answer is equal to the probability that's asked in the question to find out is equal to n divided by 3n divided by 2. So the answer is 2 by 3, correct? So the answer to the question is 0.666, say 0.67. Okay. So I think it's clear to everyone. If you're having some questions, you can ask now. Otherwise, you can ask at the end of this session. Okay. So I will go to the next question. This is also a fairly simple question. There is no need of explanation for this question. You can simply tell the answer. Anyway, I'll read out the question for the sake of completeness. Let capital X1, X2, and capital X3 be independent and identically distributed random variables with the uniform distribution on 0, 1. Okay. So now the question is to find the probability. This probability of X1 is the largest. So there are 3 random variables, X1, X2, X3. They are IID. IID means they are independent. All these 3 random variables are independent and they are identically distributed. And what is the distribution? X1, X2, say Xi. I will call in general. Xi is distributed uniformly in the interval 0 and 1. Correct? So I can be 1, 2, or 3. All the 3 random variables are distributed uniformly in the interval 0 and 1. So now the question is probability of X1 is the largest. Can somebody tell the answer straight away? Any clue? Any idea? Okay. So they are identically distributed means what? All of them are having the distribution, this distribution uniformly between 0 and 1. So what does this mean? Uniformly distributed in the interval 0 and 1. So this X1, X2, and X3 can take any real value that lies in between 0 and 1. correct? With probability density function f of say x1 equal to 1, correct? For all x1 belongs to 0, 1. So it's just like the previous random variable. I hope all of you know what a random variable is, right? It's a mapping from this probability space to real numbers, correct? So now this random variable can take any real value between 0 and 1 with equal probability or with uniform distribution. So now say x1 can take any value in between 0 and 1, x2 can take any value in between 0 and 1, x3 can also take any value in between 0 and 1. So what is the probability that x1 is the largest? Any idea? I can't see any answers in the chat window. Okay, then I will proceed. I will tell the answer straight away. It's fairly straightforward. So all the three random variables are independent, right? And also they are identically distributed. What does that mean? Probability of, so I will write something. Probability of x1 is largest. This is something that is asked to find out, right? Is this equal to probability of x2 is largest? Is it equal to probability of x3 is largest? Or what is the reason? Because they are identically distributed, correct? And they are independent as well. So because there is no preference for x1, x2 or x3. So these three probabilities must be equal, right? Do you agree? Now can somebody tell the answer? What is the probability of x1 is largest? So out of these three, so there are three random variables. We are getting a realization of the random variable. So this largest comes when there is realizations, correct? These variables, these random variables can take any value in between 0 and 1. So since you agree with this statement, now can you tell the answer? What is the probability of x1 is largest, or what is the probability of x2 is largest? So anyway, out of these three, one has to be the largest, right? So I can write this as well, right? x1 is largest plus probability of x2 is largest plus probability of x3 is largest. What is this sum? What is this sum?
1.
Yeah, this must be equal to 1. I think somebody told the answer in the chat window. Yeah, it's correct. So probability of x1 is largest. What is the value? It must be equal to 1 by 3, isn't it? Does everybody agree with this? Okay, I hope it's fairly straightforward. Yeah. Okay, then we will move on to little bit like difficult question. Not difficult, but slightly uh, advanced concept of conditional probability. I hope all of you must be knowing this, but still I will revise some of them. Okay, so before getting into the question, I will explain something about conditional probability. Okay, suppose there are two events, A and B. Usually probability is defined on events, right? So probability of, say, what is the probability of, in the previous question we have seen x1 is the largest. So I am conducting an experiment. I am taking a value of x1, I am taking a value of x2, and I am taking a value of x3, and my event is x1 is largest. So there are different possibilities, right? Either x1 can be the largest, or x2 can be the largest, or x3 can be the largest. So I am considering one such event, the event is what? X1 is largest. So similarly, the probability is defined on events, not on random variables. You have to be careful here. Probability is defined on events. Suppose A and B are some events. It can be anything. So while I'm tossing a coin and I can define an event, the output is head, that's an event. The output is a tail, that's another event, right? So in such a way, we can define a lot of events, and probability is defined on events. Suppose A and B are events, and then the conditional probability of A given B is defined as probability of A intersection B divided by probability of B. And probability of B is not equal to 0. That's what we assume. Okay, B has to be having a probability that is not equal to 0. Probability of B must be a non-zero value. So then we can define the conditional probability of A given B in this way. Okay, what is conditional probability first of all? So what is the meaning of this probability of A given B? The meaning of this is that the probability of event A to be true given that B has already happened. The event B has already happened, that is known, and given that fact that B has happened, what is the probability of the event A? Okay, I can give an example. Say I'm throwing a die that has 6 faces. Okay, 1, 2, 3, 4, 5, 6. These are the 6 faces, right? And it's an unbiased die in the sense that probability of the outcome is 1 by 6, outcome equal to 2 is 1 by 6, outcome equal to 3 is 1 by 6, and all the faces are equally likely to appear while throwing once. Okay, so I am defining an event B. The output is an even number. Then I am defining another event, output is equal to 2. Okay, output means not output, outcome. Sorry, not output. Outcome is an even number and outcome equal to 2. So now what is the probability of A given B? Can somebody tell this? Without going into the definition of A given B as I have given, you can tell the answer, right? When I tell you that B is correct, B has happened, or in the other way, the outcome is an even number. If it is given, then what is the probability of outcome equal to 2? Initially, probability of A, that means probability of outcome equal to 2 is 1 by 6, right? Yeah. Now, what is the probability of A given the fact that B has happened? Exactly. This is 1 by 3. What is the reason? When I tell you that the outcome is an even number, that is the event B has happened, then the event space has reduced, right? Then the outcome cannot be equal to 1 or 3 or 5, correct? So now the probability of getting 2 is what? That is equal to, from this you can see now, probability of A given B. Now let us apply the definition. It's equal to probability of A intersection B, or the joint event. Sometimes we will denote it with probability of A comma B. Okay, and divided by probability of B. So now what is the probability of B? First of all, outcome is an even number. What is the probability of that? So out of the 6 faces, 3 are even numbers, right? So what is the probability of B? Somebody? Probability of B equal to?
1 by 2.
Exactly, it's 1 by 2. Now what is the probability of A intersection B? Intersection means probability of outcome equal to 2, and outcome is an even number. What is the probability of this? This intersection means outcome equal to 2, right? That means the probability is 1 by 6, correct? Exactly. It's 1 by 6. Now, what is probability of A intersection B? This is 1 by 6 divided by 1 by 2, applying the definition, this definition. So now this is equal to 1 by 3. So this is precisely what we have seen without this definition. But this is the systematic way of finding the conditional probability. In some questions, you may not be able to tell the answer as in this example. You cannot, because in this case, you can see A intersection B, the event A intersection B is nothing but event A itself, right? The outcome is 2, because this A is a subset of event B, correct? I hope it makes sense. So that's the reason why we could tell the answer very easily, even without getting into this definition. But for most of the questions, you may require to know this definition of conditional probability. So the conditional probability of A given B is defined as probability of A intersection B divided by probability of B. Okay, provided that probability B is not equal to 0. That's because otherwise this denominator will go to 0 and you will have all sort of problems, right? So in order to avoid that, while defining the conditional probability itself, we will say that probability of B not equal to 0. So yeah, now let us get into the question. Okay, so first you can read the question yourself. By the time I will erase some of these jargons. Yeah, now the question is as follows. Consider the Z channel given in the figure. So don't get carried away by this term Z channel. The question has nothing to do with Z channels. Okay, so why is it called an Z channel? So the diagram looks like an Z, right? It looks like an Z. That's why it's called an Z channel given in the figure. The input is 0 or 1 with equal probability. Okay, so whatever is written here on top of these arrows here, 1, 0.25, 0.75, all these values are the transition probabilities. Okay, so the channel can either have 0 or 1 as the input. Similarly, it can have either 0 or 1 as the output. Now the question is, if the output, so I am observing the channel output and the channel output is 0, then what is the probability that the input is equal to 0? Is the question clear to everyone? So now I think the question is clear to everyone. Now let us see the channel very carefully. So the channel can have either 0 or 1 as the input. And it is told that the input 0 or 1, they are with equal probability. So I will denote the input with a random variable x, or I will denote the input with x and output with capital Y. What is the probability of input equal to 0? Can somebody tell that? It is already given. With equal probability, 0 and 1 are equal probability means it's 0.5. Correct. It is 1 by 2. Similarly, probability of x equal to 1 is also 1 by 2. Correct? Because it is given here with equal probability. Now, suppose the input is 0. Then the output can be only 0, right? If the input is 0, then the output is 0 with probability 1 that is given here. So the question is, what happens when the input is 1? When the input is 1, the output can be either 0 or 1, correct? With probabilities 0.25 and 0.75 respectively. That means if the input is 1, the output is 0 with probability 0.25. What is that probability? So the probability of the output y equal to 0 given x equal to 1, correct? That is equal to 0.25. Does everybody agree with this? So given means if the input is 1, then what is the probability of output y equal to 0? That is 0.25. And probability of y equal to 1 given x equal to 1 is equal to 0.75. And one more thing, very trivial thing, I will erase these things. Okay, yeah. And probability of y equal to 0 given x equal to 0 is what? What is this probability? This is 1, correct? So if the input is 0, then the output will be definitely 0. It cannot be 1. Or in other words, probability of output being 1 if the input is 0 is 0. This is a 0 probability event. That means that event will never happen. If the input is 0, then the output cannot be 1 according to this given figure, right? Now, what is the probability that they are asked to find out? The question asked to find out the probability of somebody has already told the answer. Very good. So the probability that the input is 0 given output is 0. That means probability of, so it's asked to find out x equal to 0 given y equal to 0. That means if the output is 0, that means if y equal to 0, then what is the probability that the input is also 0? So we are asked to find out this probability of x equal to 0 given y equal to 0. Now let us apply the definition of conditional probability. Okay, what does that mean? This gives x equal to 0 comma y equal to 0. Instead of putting the intersection symbol, I'm just using a comma here. Okay, given probability of y equal to 0. So I'm just using the definition. So a lot of people are answering. All of you are correct. Okay, so now what is the probability of x equal to 0 given y equal to 0? This again I can rewrite in a different way, correct? Probability of y equal to 0 given x equal to 0 into probability of x equal to 0. How is that possible? I am just rewriting the numerator. So how is that possible? Again, come to the definition. Probability of a given b is nothing but probability of a intersection b divided by probability of b, right? So I can write it as probability of a intersection b equal to probability of a given b into probability of b, correct? In a similar fashion, I can write like this as well, right? Probability of b given a into probability of a, correct? Because a intersection b and b intersection a are the same, correct? So I'm just using the definition here. So the joint probability, the intersection probability of x equal to 0 comma y equal to 0 is nothing but p of y given y equal to 0 given x equal to 0 into probability of x equal to 0 whole divided by probability of y equal to 0. Now we know all these values. So just need to substitute this. So y equal to 0 given x equal to 0 is, what is the value? Now we need to find one more probability, right? What is that probability? Probability of y equal to 0. How will we find out that? What is this probability? So in how many ways y can be 0? Y can be 0 in two different ways, right? Given x equal to 0 plus probability of y equal to 0 given x equal to 1. So when input is 0, the output can be 0. Similarly, when input is 1, the output can be 0, right? Here when input is 0, the output can be 0, and similarly when input is 1, the output can be 0. So what are these probabilities? I think I'm making a mistake here. These are commas, correct? So this is nothing but probability of y equal to 0 given x equal to 0 into probability of x equal to 0 plus probability of y equal to 0 given x equal to 1 into probability of x equal to 1, right? Any questions? So basically, y can be 0 in two different ways. One is when x equal to 0 and the other one is when x equal to 1. These are two joint events. So we can write the total probability like this, correct? And again, using the definition of conditional probability, I can write this part like this and this second term like this, correct? So now we know all these probabilities. P of y given 0 y equal to 0 given x equal to 0 is what? This probability, right? That is 1 into probability of x equal to 0 is half plus probability of y equal to 0 given x equal to 1 is 0.25, right? Y equal to 0 given x equal to 1. That is 0.25 into x equal to 1 is half. So this is nothing but 1.25 divided by 2. Correct? So now we need to find this probability, right? So here we know the denominator 1.25 divided by 2 and the numerator is nothing but 1 into half. So this is nothing but 1 divided by 1.25 or it's equal to 4 by 5 which is equal to 0.8. So the answer to the question is 0.8. Is it clear to everyone? Any questions? If not, we will see one more question from conditional probability. That's not exactly like this, but that's also using the definition of conditional probability. I hope this is clear to everyone. If you are having some question, you can ask now. Okay, so far so good. Now, this is again one more question from conditional probability. So the question is as follows. Parcels from sender S to receiver R pass sequentially through two post offices. Each post office has a probability 1 by 5 of losing an incoming parcel independently of all other parcels. Given that a parcel is lost, the probability that it was lost by the second post office is. Again, it's a numerical answer type question. So there is a sender and there is a receiver R. And there are two post offices in between. So it goes from S to, say, post office P1. Then from P1 to it goes to another post office, say P2. Okay, then it goes to the receiver. So it happens sequentially. That means all the parcels will go from S to P1, then P1 to P2, then P2 to R. Okay. Now, each post office has a probability 1 by 5 of losing an incoming parcel. That means here there is a probability that 1 by 5. That means if a parcel is coming, then with probability 1 by 5, the parcel will be lost from post office 1. Then again, so some parcels will from P1 to P2, the remaining parcels will come. Some of them will be lost at P1, right? And the remaining will come to P2. And again, at P2, there is a probability of losing the incoming parcels. So again, the probability is 1 by 5. Then from P2 to R, correct? To the receiver. So now the question asks to find out the probability that the parcel is lost. So we need to find the probability that the parcel is lost by the second post office, given that the parcel is lost. That means we know that the parcel is already lost. Then what is the probability that it was lost at the second post office? So at the receiver, we can know whether the parcel is lost or not, right? Because if the receiver does not receive a parcel, it knows it is lost. So, but that loss could have happened either at P1 or at P2, correct? Now the question is, what is the probability that it was lost by the second post office? That means the parcel was lost at P2. Okay, I hope the question is clear. So now, first of all, we can find some probabilities, correct? So first of all, what is the probability of losing a parcel? Can somebody tell the answer? What is the probability that somebody? Okay. So how can we find the probability? So first of all, the question is probability. It is asked to find out the probability of the parcel lost at P2 given the parcel is lost. Correct? This is the probability that they have asked to find out. So using the definition of conditional probability, we can write this as parcel lost at P2, comma parcel is lost, divided by probability of parcel is lost. So you are saying the answer? Okay, I hope the answer is correct, but I need to do that. I haven't done that. Yeah, from the values that you have written, it appears it's correct. Anyway, I will do for others whoever is not clear with the answer. Okay, so what is this intersection? Parcel lost at P2 and parcel is lost. That means the parcel is lost. Correct? At P2, parcel lost at P2. If a parcel is lost at P2, that automatically implies that parcel is lost. So the intersection will be parcel lost at P2, correct? Probability of parcel is lost. So now let us find out these two probabilities. First, let us find out the denominator, probability of parcel is lost. So this is nothing but 1 minus probability of parcel is not lost, correct? So what is the probability of this? Parcel is not lost. That means parcel has successfully passed from P1 and successfully passed from P2. That means it is not lost at P1, not lost at P2. So what is the probability of not losing at P1? That is 1 minus 1 by 5. That is 4 by 5. So again here, the probability of not losing a packet at P2 is 4 by 5. So the total probability, because it is told that an incoming parcel is lost independently of all other parcels. Correct? It's an independent, both these are independent events. Losing at P1 and losing at P2. They are independent events. So with probability 4 by 5 into 4 by 5, the parcel will not be lost. That means this is equal to 1 minus 16 by 25. Correct? That is equal to 9 divided by 25. With this probability, the parcel will be lost. Correct? Now, what is the probability that, now let us find out the numerator, probability of parcel lost at P2. That means the parcel has successfully passed the post office P1. What is the probability of that? That has a probability of 4 by 5. And it is lost at P2. That means it has a probability 1 by 5. So the probability of parcel lost at P2 is nothing but 4 divided by 25. So the required solution, the answer, the parcel lost at P2, given parcel is lost, is equal to 4 divided by 25 divided by 9 divided by 25. So the answer is 4 by 9. So this is what you were telling, right? I hope. Yeah, correct. 0.44. So the answer to the question is 0.44. Any question from this? Any doubts? Anybody else think? Some of you have understood the question very clearly and they solved it even before I'm telling the preliminaries. So others, any doubts? Okay. Now, yeah. Now let us see one question from expectation of random variables. First, I will start with a fairly simple question. Then we will see, yeah, more advanced question. Okay, it's again a question from 2014. Hope all of you are able to see the question. So the question is as follows. Let capital X be a random variable which is uniformly chosen from the set of positive odd numbers less than 100. What is the expectation of X? Okay, so first of all, what is the expectation of a random variable? Suppose some random variable, capital Y. Okay, this capital Y can take values y1, y2, say up to yk. This can be an infinite set as well. Now, for the time being, let us assume that capital Y, the random variable, can take finite number of values y1, y2 up to yk with probabilities p1, p2 up to pk. Okay, then the expectation of Y is defined as summation over all the values that Y can take. That means I equal to say 1 to capital K pi into yi. This is the expectation of Y, capital Y. Now coming to the question. So the question talks about a random variable capital X, and the random variable is uniformly chosen from the set of positive odd numbers less than 100. That means what are the values that X can take? X can take values 1, 3, 5 up to 99. Correct? What is the probability of X equal to 1? Can somebody tell? Somebody tell the answer. It is told that it's uniformly chosen from the set of positive odd numbers. So how many positive odd numbers are there less than 100?
50.
Yeah, total 50 number of odd numbers are there. Then what is the probability of X equal to 1? That's nothing but 1 by 50. Correct? Similarly, the probability of X equal to 3, X equal to 5, everything up to say X equal to 99. All these values are nothing but 1 by 50. Correct? Does everybody agree with this? Now the expectation is fairly straightforward to find out. Expectation of X equal to summation I equal to 1 to 50. Probability of X equal to say some 2i plus 1, right? Not 2i plus 1, 2i minus 1, right? I'm not complicating that. So anyway, over the summation is over all the odd numbers, and this can be written as 1 into 1 by 50 plus 3 into 1 by 50 plus 5 into 1 by 50 up to 99 into 1 by 50, right? This is the expectation. This is nothing but 1 plus 3 plus 5 plus up to 99 divided by 50. So what is the sum in the numerator? Can somebody tell the answer very quickly? So the sum of first n odd numbers is nothing but n square, right? So if you want other ways, you can find out this arithmetic progression. You can easily find out the sum, or in other way you can find in you can use different methods to find the sum. So the sum of first n odd numbers is nothing but n square. So here it is 50 odd numbers we are considering, right? So the sum of the numerator is 50 square, and divided by 50 is again 50. So the answer is 50. So the expectation of X is nothing but 50. So you can find this sum in different ways. I can tell one other method. So here 99 plus 1 is 100. Say here 97 will be there, plus 3 is 100. 5 plus 95 is 100. Similarly, it goes like that. 49 plus 51 is also 100. So how many such sums will be there? 25, right? 1, 3, 5 up to 49 into 100. 25 into 100 divided by 50. So this is again nothing but 50. So there are different ways to find out the sum in the numerator. Correct? So you can find the sum in any way, but it's it should be correct. That's it. So the simplest way is using this formula. The sum of first 10 odd numbers is n square. So does everybody convinced with this answer? So here, even though it's asked to find out an expectation of a random variable, at the end, it boils down to finding the average of these 99 numbers, correct? What is the average of the first 9? Average means the empirical average. You're just adding and dividing by the total number, correct? So what is the reason for that? It's because it's a uniformly distributed random variables, because all the things are having probability 1 by 50. That means x equal to 1 has probability 1 by 50, x equal to 3 has probability 1 by 50, and it goes like that. And that's the reason why you can see here, right? If you see here, this is nothing but the average of first 50 odd numbers, correct? So it happened because of the uniform distribution. That's what I wanted to tell you. Okay. So if the distribution was something different, then it will get different forms. Okay. So far so good. Now we will see slightly more advanced question. Again, here we have seen a finite set, right? 1 to 99. Only 50 possibilities are there. Now we will see an infinite possible set, and the probabilities will be different. So some of you might have seen this question, because in the previous phase as well, I have discussed this question, not in detail, but I have solved a similar question and I have told them to try to solve this question. And this is a very common pattern that happens, or that appears in gate exams, especially in EC, very frequently. Okay, so I have seen at least 3 questions of the same sort in the last 10 or 12 years. So I think this is the most maybe difficult question that comes from the probability topic. It's not very difficult at all if you know the method to solve this. This is very easy, in fact, so to solve this question. But for if you're seeing the question for the first time, it appears as if it's a very difficult question. That's it. It's not a difficult question at all. Okay. So the question goes as follows. Passengers try repeatedly to get a seat reservation in any train running between 2 stations until they are successful. If there is 40% chance of getting reservation in any attempt by a passenger, then the average number of attempts that passengers need to make to get a seat reserved is. Okay, so I will tell the question. There is a station A and there is another station B, and passengers need to take reservation. Some train is running between A and B. Lot of trains will be there. Okay, and they want to get a seat reservation in some of the trains, or in one passenger needs to get one reservation, right? So the passenger, say I am the passenger, I am keep on trying to book reservation. So what is the chance of getting the reservation in the first attempt? That is 40%. Okay. Again, if I don't get a reservation in the first attempt, then I will try again. Again, it can fail, right? Because there is a chance of 40% of getting a reservation. That means there is a probability of 0.6 of not getting a reservation in any attempt. Correct? So if I don't get in the second chance, I will again try for the third attempt. I will keep on trying until I get a ticket or until I get a reservation. So now the question is to find the average number of attempts that passengers need to make to get a seat reserved is. So this is the question. I hope the question is clear to everyone. So again, suppose the random variable I am defining x. This x means the number of attempts the passenger need to make to get a seat reservation. And it's asked to find out the average number. That means the expectation of this random variable x. So this x can take any integer value, right? 1, 2, 3, it goes to infinity. Correct? It's an infinite set. So that means in the first attempt, the passenger can get a reservation, or in the second attempt, or in the third attempt, and it goes like that. Correct? Now, the expectation of x is nothing but summation I equal to 1 to infinity probability of x equal to I into I, right? Or in other words, the probability, this is equal to 1 into probability of x equal to 1 plus 2 into probability of x equal to 2 dot 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 dot. Correct? Up to this, is this clear to everyone? So now it's just a matter of finding this probability of x equal to I and finding this sum. Agree? First of all, can somebody tell this probability of x equal to 1? That means I'm getting the reservation in the very first attempt. What is this probability? Somebody? This given in the
0.4.
yeah, exactly 0.4. What is this probability? X equal to 2.
0.6 into 0.4.
Exactly 0.6 into 0.4. What is the reason? In the first attempt, x equal to 2 means I am getting the reservation in the second attempt. That means in the first attempt, I failed to get the reservation. What is the probability of failure while attempting a ticket booking? That is 1 minus 0.4. That is 0.6. In the first attempt, I failed to get a ticket, 0.6 with probability. In the second attempt, I get a seat reservation. For that, the probability is 0.4. Now, what is the probability of x equal to 3? That is equal to 0.6. That means I failed in the first attempt. Again, into 0.6, I failed in the second attempt. But in the third attempt, I got the reservation. So the probability is 0.6 into 0.6 into 0.4. Correct? Now, what is the probability of x equal to I? That means exactly at the ith attempt, I got the seat reservation. That means I failed in the previous I minus 1 attempts. Correct? That means that has a probability of 0.6 into 0.6 into 0.6 I minus 1 times. That means 0.6 power I minus 1 into 0.4. That means exactly at the ith attempt, I got the seat reservation. Now, it's just a matter of computing the sum. So this is the slightly tricky part in this question. I into 0.6 power I minus 1 into 0.4. Do somebody know the answer for this summation? This is an arithmetic or geometric progression. Okay. So I will tell how to calculate this sum. Okay. Let us expand this sum. Substitute I equal to 1. That means 1 times, correct? 0.6 power I minus 1. That is 0.6 power 0. That is 1 into 0.4. That is nothing but 0.4. Correct? When I substitute I equal to 2, I will get 2 into 0.6 power 2 minus 1 is 1. 0.6 into 0.4 plus 3 into 0.6 square into 0.4. 4 into 0.6 cube into 0.4. It goes like that. Correct? So now I will slightly rearrange this sum. 0.4, let it be as such. Now the second one, 0.6 into 0.4, 2 times, right? Now I will write like this. The third one, 0.6 square into 0.4 plus 0.6 square into 0.4 plus 0.6 square into 0.4. It's how many times? 3 times. Now 0.6 cube into 0.4, 0.6 cube into 0.4. How many times? 4 times, right? 0.4. Correct? So you may be wondering, what am I doing? Because I am complicating the things even further. Correct? Now I got infinite number of infinite summations. Agree? But now there is one fortunate, like I am fortunate that I know the sum of each of the rows. There will be infinite such rows, but I know the sum of all of them. What is the reason? because all of them are geometric progressions with infinite. Um, it's an infinite geometric progression, right? Infinite geometric series, in fact. So suppose what is a geometric series? A into R, geometric progression. This is a progression. AR square, AR cube, correct? So A is the first term and R is the common ratio. So what is the sum of this progression? AR square, AR cube, etc. This is nothing but A divided by 1 minus R. This is the sum of a geometric progression, infinite geometric progression having first term A and common ratio R. Now let us find out the sum of each of these rows. First row has first element 0.4 and common ratio 0.6, right? First term is 0.4 into 0.6 will give second term, into 0.6 will give the third term, into 0.6 will give the fourth term. It goes like that, correct? So the sum is 0.4 divided by 1 minus 0.6. That is again 0.4 divided by 0.4 is 1. Correct? Now what is the sum of the second row? So here the only difference is that first term is 0.6 into 0.4. The common ratio is again 0.6 itself, right? This term into 0.6 will give the next term. This term into 0.6 will give this term, correct? So here the first term is 0.6 into 0.4 and the common ratio is 0.6, 1 minus 0.6. That means this will get cancelled out and the sum is 0.6. So what is the sum of next row? It's 0.6 square. This is 0.6 cube. Now you can see again, vertically we are having a geometric progression, having first term equal to 1 and common ratio again 0.6. So the total sum is 1 divided by 1 minus 0.6. That is equal to 1 divided by 0.4 and which is equal to 2.5. So the sum of this series is equal to 2.5 and that is the expectation and the answer. So the answer to this question is 2.5. Does everybody agree with this? In general, I can write this sum as expectation of sum, not expectation, I'm writing this sum, okay? Summation I equal to 1 to infinity I into some 1 minus p power I minus 1. Suppose instead of 0.4, if I have p, this is the sum, right? If I substitute p equal to 0.4, you will get this sum. Correct? What is the sum of this? This is nothing but 1 by p. So from the question itself, you can directly tell the answer to these kind of questions. So we know p equal to 0.4. So the answer to the question is 1 by 0.4, that is 2.5. Does everybody agree with this? Any questions? Any doubts? Okay. So I will quickly tell one more question. You can tell the answer. Yeah, this is something, yeah. Now, suppose this is the question, you can tell the answer. Okay. So can somebody tell the answer to this question? Just looking at the question. A fair die with faces 1, 2, 3, 4, 5, 6 is thrown repeatedly till 3 is observed for the first time. Let capital X denote the number of times the die is thrown. The expected value of capital X is. Can somebody tell the answer? So do you find any similarity between this question and the question that we have solved just now?
6 answer.
Yeah, the answer is 6. Does everybody agree with that? Because here, what is the probability of getting a 3? That is nothing but 1 by 6. And the question is nothing but we are keep on throwing the die until a 3 is observed. That means we can go up to infinite times, right? And the summation will be just like the previous cases. Summation I 1 minus 1 by 6 whole power I minus 1 into 1 by 6. So what is the sum? Nothing but 1 by 1 by 6. So the answer is 6. Okay. Okay, now we will discuss one more question. because somebody asked to solve this question in the beginning. So this is a question that we have discussed previously in the phase 1 of this NPTEL gate as part of that discussion. Okay, so this is again a question that is related with conditional probability. So by doing this question, we will wind up the session. Okay, so I hope the time is already 6:09, so I will try to finish it up very quickly. Okay, so the question is as follows: a box contains the following 3 coins. Okay, there are 3 coins and each coin is having some speciality. The first coin, a fair coin. The first coin is a fair coin with head on one face and tail on the other face. Okay, and the second coin, it's a special coin, a coin with heads on both the faces. And the third coin is a coin with tails on both the faces. Okay, so it sounds very strange. The question is like this. Okay, so we have to live with the question. So the question is as follows: a coin is picked randomly from the box and tossed. Out of the 2 remaining coins in the box, 1 coin is then picked randomly and tossed. If the first toss results in a head, what is the probability of getting a head in the second toss? Okay, so a box contains 3 coins. One is a fair coin with head and tail on the faces, and the second coin has head on both the faces, and the third coin has tails on both the faces. Now, I am doing an experiment. From the 3 coins in the box, I am picking up 1 coin randomly. Okay, and I am tossing that coin, and I am keeping that coin aside. And how many coins are remaining in the box? There will be 2 coins, right? And out of the 2 remaining coins in the box, 1 coin is then picked randomly and tossed. Okay, and the question is, if the first toss results in a head, okay, that's a given that the first toss resulted in a head, what is the probability that a head in the second toss? Okay, I will write out the probability. So the question asks to find out the probability of getting H in the second toss given the first toss resulted H. Okay, so this is the probability that is asked to find out. I hope everybody agree with this. Now again, let us use the definition of conditional probability. It is nothing but getting head H in second toss, comma, head in getting H in first toss, whole divided by probability of first head in first toss. Correct, I am not writing everything in detail, but I hope these probabilities are clear to everyone. What are the probabilities that we are looking for? Correct. Now let us find out the denominator first. Probability of H in first toss. Can somebody tell what is the probability? So in how many ways the first toss can result in a head? That means, suppose if I take so what I'm doing is I'm taking 1 coin randomly from the box that contains these 3 coins. Correct? Suppose if I get the second coin, will I get it? Suppose if I get the third coin, if I get that, will I get a head upon tossing? Is it possible to get a head if I pick the third coin? It's not possible, right? Because the third coin has tails on both the faces. So in how many ways the first toss can result in head? There are 2 possibilities. The first possibility is that I am picking up the first coin that has a probability 1/3 into I need to get a head upon tossing, because there is head and tail, right? What is the probability of getting a head? So I will write in detail. So it means probability of, I am picking coin 1 and upon tossing I am getting head, plus probability of coin 2, picking up coin 2. So probability of coin 2 means probability of picking up coin 2, okay? Because coin 2 has heads on both the faces. So the tossing of the coin doesn't really matter. It automatically gives the outcome to be head because it has head on both the faces. Okay, is it clear? Now what is this probability? The first probability is nothing but 1 by 3. That is the probability of picking up coin 1, and getting a head has probability 1 by 2. And the second one, probability of getting coin 2 while randomly picking 1 from the 3 is again 1 by 3. So this is equal to 1 by 6 plus 1 by 3, which is equal to 1 by 2. Okay, that is the denominator. Now let us find the numerator. Probability of getting H in first and second tosses. In first and second tosses. That is the meaning, right? So I need to get head in the first toss as well as in the second toss. Correct? So in how many ways this can happen? The first possibility is that probability of I need to pick coin 1 first, right? And I need to get head upon tossing. And from the remaining 2 coins in the box, while I am picking 1, I should get coin 2. This is one possibility. What is the second possibility? From picking the first time, I should get coin 2. If I get coin 2 means both the faces are heads. Correct? Both the faces are heads means I will anyway get head upon tossing. Second time while I am picking the coin, I should get coin 1. Right? If I get coin 3, I will never get a head because it has tails on both the faces. And upon throwing, I should get a head. So what are these probabilities? The first one has probability coin 1, picking up is probability 1 by 3, and getting head has probability 1 by 2. And for the next time, I am choosing, if I have taken coin 1 for the first time and I have kept it aside, I am taking from the remaining 2, right? Out of the 2 remaining coins in the box, 1 coin is then picked up randomly. Then the probability of getting coin 2 is 1 by 2. Correct? And the second possibility, this probability, first I am picking coin 2, that has a probability 1 by 3. And the outcome will be definitely head because it has heads on both the sides. For the next time I am picking up coin from the remaining 2, I should get coin 1. That has probability 1 by 2. And upon tossing coin 1, I should get head. That has probability 1 by 2. Correct? So this is equal to 1 by 12 plus 1 by 12. That is equal to 1 by 6. So now I got the numerator to be 1 by 6 in this conditional probability 1 by 6. And the denominator, probability of getting heads in the first toss, is nothing but 1 by 2. So the answer to the question is 1 by 3. Okay, is it clear? So the option is option B. Is it clear? Okay, if you are having some questions, you can ask from any of the 6 or 7 questions that we have done today. If not, we will wind up the session and we will meet again on next Tuesday, 6 o'clock. Okay, next week we will discuss some questions related with signals and systems. Yeah, next week I will discuss some questions related with communications. Okay, or maybe signals and system itself. Okay, so thanks everyone. Let us wind up the session.
Thank you, sir.
Yeah. Okay.
Thank you, sir.
Yeah. So I'm